Now, the good thing about the match properties is in my templates, I'll normally apply the manufacturer's parts to their template. Then when I start a drawing out, instead of applying parts, I'll just pick the manufacturer's elevation here and match properties, and automatically you don't have to type anything in. You just match properties, and it's very easy to apply parts. So once I've applied my parts, next thing I'm going to do is I'm going to label my elevation because there's elevation level tags. So I'm going to say this is elevation E1. If you want to have a project phase like phase 2, building 1, a wall location such as west or east or north, what floor level it's on, this is the first floor, and if you have more than one required, a lot of times a drafter will draw and say required thus 4, you would just put in 4. Click apply, select the elevation, and it'll apply all these tags to that elevation. Okay, so on my next one I'd have an E2, project phase 2, building 1. This might be the north wall. Floor level 1, thus required 2. I'll apply it to this one here. And at that point, it applied elevation level tags. The reason that's so nice is when you export this out into Extreme Cut Optimizer, it will pick up those locations. You can actually sort by elevation. You can sort by floor level, part type, by building. However you want to sort your parts to cut them. And now what I'm going to do is I'm going to go back to Extreme Data, and I'm going to apply my tags. And this is Add Tags to Drawing. And I will apply the assembly and all the part tags. And I'll tag selected elevations. I'll make my tag size 2 inches. I'll pick elevation E1. What it's going to do is it's going to run through and it's going to apply the tags onto the elevation. And as you see, my elevation is completely tagged. I have B1-A, B1-B. For my back member, the length had changed on this, same part. B2-B, the actual part changed. And I'll show you where that comes in handy. Let me run my tags on my other one, even though I didn't do many of these. I'll do my assembly tags, my part tags. I'll shrink that down to size. I'll select the second elevation. And now I'll apply the tags to my second elevation. Now, not only can I tag the entire elevation or all the parts, I can actually go back and I can tag just a certain tag if I want to do just the cover caps. And we'll make that a size 5. So I can do a tag drawing on the cover caps. So a lot of times your cover caps get cut last. So when you cut them, they might want a tag drawing out in the field. Where's these cover caps go? And this would show you your cover caps exactly where they go on the drawing. Okay, but what I'll do is I'll put that back to assembly and part tags. Make that 1.5. So it gives you different levels of tagging. You can do a back member tag, you can do a tag drawing of your pressure plates, whatever you want to do a tag drawing of, or multiples. You could have tag drawings of all your different parts. And here that is. And now what I'm going to do is I'm going to put out a list. I'm going to go back to the parts application dialog. I'm going to go add table to drawing. I'll select both elevations. And now I can select where my table is going to go. And I can sort by many different ways here. I can do a full list, which I'll do real quick. And this is actually going to put out a complete list with everything in the drawing, every part that's in that drawing right there. I was calculating everything in the drawing here. And once it's done calculating everything in the drawing, it's going to put out a complete list of every part in. And this is where your part tags come in. I've got KW001, I got a back member. My part tag is B1-C, my length, my width, my finish, color. If I'd add any angles, my elevation, floor, building, thus required. And it's actually multiplied that entire list because I had required thus 4, required thus 2. And you'll notice these part tags B1-C. This would be a B1-C. So that would be the back member there. Okay. Then I could put out a quantified list. I'll go back and I'll select my drawing. And this will allow me to put out a quantified list, and I'll put this table right next to it of parts, list with quantities. And that's going to quantify my list. So instead of having one of each, it might have 13 B1-A back members. And there's my quantified list. And what I have here is I have 16 KW004 back members, 12 KW01s with the part tags and the corresponding links. Then I could actually put out my tables for my fab sheets. And this is the one I like the most. So now I'll go back in, pick where I want my table, and I'll do by part description. Then I'll do a tag list. This is going to pop up every tag I have in the program, and I'll do the B1s. Click OK, and that's going to put out all my B1s for my fab sheets. So now here I got my B1 fabrication list, and this tells me I need 10 KW001s back member, B1-D, and the D, A, B, C, D represents the length. So you can paste this right into your fab sheets. You can go back in when it comes to assembly. You can put out an assembly list. So I'll put part description, assembly list, and this is going to list all the assemblies. And assemblies is a complete assembly with all the parts in it. So I'll just start with a SIL 1, an S1. And this is telling me that for S1 assembly, this is what I need to assemble that. I need 4 KW001s, B1-As. So this is the parts I would need to actually assemble this. Now if you wanted to do a check of the parts in your drawing to make sure your parts are correct, or if you had a question of what part went where, you could actually put out a list of a checklist. And at that point, it's going to put out a list. It's going to number everything 1, 2, 3, 4, 5, 6, 7, so you can locate an actual part or an assembly in the drawing exactly where it's at. And then once again, if you wanted to actually take this this data, you could export that out anywhere you want. And here it gave me a full list. And you'll notice I have a 1, a 2, a 3, and that would correspond in the drawing. It'll actually label everything 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you could find the exact location. Here's part 29. So you can look for part 29. It'll tell you what's in part 29. Okay, so that's XtremeFab. Like I said, it's meant to allow you to actually apply parts to any AutoCAD 2D elevation rapidly, quickly, and the learning time on this is about 20 minutes. I think once you watch this video, you've already known it now. Say you had to change some of these. If you wanted to stretch this elevation, you could. And at that point, once you stretched it, you go back into Extreme Data, and you just do Update All tags, and it will actually run through, retag it, update all your information, and it's that easy to update the information after you tag it, so you don't have to reapply parts or anything like that. And these lists are now ready to send out. For optimizations, what I'll do is I'll export this list. Oops. I'll export this list, and I can save this out as a CSV file wherever I wanted to save it. We'll just call this a school job, and I'll save that out. And that's how easy it is to export your list out. And I'll go get that list. And there's the CSV file. I'll open that up. What I'll do is I'll save this out. once again, and I'll actually open up XtremeCut. Pardon my desktop. I'll open up XtremeCut, and you can import this list in real fast with XtremeCut and do about what you want to do with it. Now that XtremeCut's open, what I'll do is I'll import that file. I'll go to School, click Open. I already have a file map, so I'll actually just click for mapping, ignore first record. And this allows you to map the fields that are in my list that I'm bringing in to the fields that are in the XtremeCut. And since I already did the mapping, I can just click Next, click Next again. And now that complete list is now into the optimizer. And the one thing I was telling you can sort by in the optimizer, it's got all the columns, the same thing that it has in the fabrication program. So if you want to sort by floor, or if you want to sort by elevation, it's very easy. If you go to sorting tags, we'll sort by elevation, and what that'll do is it'll actually create another list for E1 and E2. So if you don't want to cut your complete material list, say if you had 20 elevations, you don't want to cut that, you can actually go in and sort that by what you want to cut. You can go into filter pieces, you can select the different elevations you want to cut. It'll actually create a new tab, say E1, 2, and 3, and at that point it's just a matter of optimizing. You go through, you optimize it. It's going to tell you what your yield is. You can accept it, open reports when it's done. I can save my drops to a list, click OK, and at that point it's going to run through, create all my list to go out and actually cut this. So this is how fast it is to once you have your elevations created, to go in and apply parts, tag your parts, create your parts list, your fabrication list, send it out to an optimizer and actually optimize this. These are our cut diagrams. These are our material summary. And that's what it did. It gave us a material summary of everything that we need. If we put the cost and the weight in there, it would give us that. Here's our bar diagrams. This is what you're going to send out to cut. It's going to tell you this is your top view. This is a 3D view of that same view. What your cuts are in here. You're going to need 2 of these bars, 18 pieces. You're going to get 96% yield. It's a bronze Kynar. And here's the description. Length, 4 pieces, 1, 2, 3, 4, and then 4 pieces of 39 and a half. And it's going to color code, your waste and all that. Then it's going to give you a cut list report, and then it'll give you labels, and it'll give you a cut diagram with barcodes if you want them, of everything you want. And that pretty much ends our demonstration. Thank you for watching.